In this video, we're going to go deeper into our discussion of digital circuits by talking about combinational logic. Before we can do that, we're first going to talk a little bit more about truth tables. Remember that a truth table describes the inputs and the output for any digital circuit. And the way your truth table is created is based on the number of inputs to your circuit. For example, take a look at this picture on the far left. This is the truth table that represents a digital circuit with two inputs, input A and input B. Notice that A and B are shown on the left and the output, which is labeled as X, is shown on the right. If you have a circuit with only two inputs, your truth table will begin with this setup right here. Keep in mind that these combinations of zeros and ones represent every possible combination you could have. If you only have two inputs, input A and input B, there's only four possible combinations of inputs that you could have. Input A and input B could both be 0. Input A could be 0 while B is 1. Input A could be 1 while B is 0, or they could both be 1. So a truth table has to describe every possible combination of inputs and then what you expect to see at the output. So if you only have two inputs to a circuit, your truth table will begin like this, where you will describe the combination of inputs for A and B here, and then you'll write the output here. If your circuit has three inputs, such as in figure B, your truth table would be set up like this. Notice that now you have 1, 2, 3 columns to represent your three inputs, inputs A, inputs B, and input C. And then you have the output column labeled as X right here. So if your circuit has three inputs, your truth table is going to look like this on the left. So if you notice, there's also a pattern here. Take a look at input C. Input C alternates between 0 and 1. 1, 0, 1, 1, all the way down. Input B has 2 zeros, 2 ones, 2 zeros, 2 ones. Input A has 4 zeros and then 4 ones. And that's a pattern you can always use to set up a truth table for a 3-input circuit. So no matter what kind of circuit you have, your inputs will always be set up like this. And then for each combination of inputs, you're going to write the output underneath the last column. If your circuit had 4 inputs, your truth table would look something like picture C. Notice we now have a column for input A, input B, input C, and input D. And if we start with the last input and work our way backwards, we're going to see the same pattern that we saw in picture B. Look at input D right here. Input D has 1, 0, 1, 1, 1, 0, 1, 1, all the way down. Input C has 2 zeros, 2 ones, 2 zeros, 2 ones, all the way down. Input B, 4 zeros, 4 ones, 4 zeros, 4 ones, all the way down. And then input A has 8 zeros and then 8 ones. This pattern will always work to set up the inputs of a truth table. So if you have 4 inputs, you will write inputs A, B, C, and D here, and you would fill your input section of the truth table in exactly like this picture shows. And then for output X, the output would depend on whatever kind of circuit that you have. So here's a few examples of a truth table with more than 2 inputs. In the previous videos, you saw the truth table for an OR gate, and in that video, the OR gate only had 2 inputs. But we can have an OR gate with more than 2 inputs. For example, we can have an OR gate with 3 inputs, as shown in this picture here. If I have 3 inputs, inputs A, B, and C, that means my truth table has to have a column for each one of those inputs. And the truth table will have the same pattern I described on the previous slide. And this describes every possible combination of inputs for A, B, and C. Now the output depends on what kind of circuit you have. In this case, we have an OR gate. Remember that by definition, the output of an OR gate will be high as long as any input is high. So if you look at our inputs here, the first row has A, B, and C all being low. And that's why the output is going to be low. Because if a 0 goes into an OR gate at input A and input B and input C, well, none of the inputs are high. So the output has to be low. But if you look at the following rows, there's at least one input that is high for every other row. Since this is an OR gate, that means the output will also be high. Notice that the output labeled as X has an expression. X equals A or B or C. Remember, plus sign indicates or. So we're not saying A plus B plus C. It's not a math problem like you've seen in other classes. Anytime you see the plus sign, it really represents or, and we say the word or out loud, not plus. So we would say that the output is A or B or C. Here's another example of a 3-input AND gate. So now we have the AND gate that you've seen before with 3 inputs A, B, and C, and we have a truth table. Notice again, if I have 3 inputs, the input section looks the same way every time. You're just filling in all those possible combinations of A, B, and C. It's the output that will depend on the type of circuit that you have. In this case, we have an AND gate. So remember that the output of the AND gate can only be high if all of the inputs are high. So you'll see in the truth table that the output is low until input A, B, and C are all high. Then the output goes high, because that's what an AND gate does. So take a minute and try to generate the truth table for a 4-input OR gate and a 4-input AND gate using what we discussed just right now. Keep in mind the pattern that we talked about for setting up a truth table and see if you can set it up for 4 inputs and then fill in the output. So take a second right now, pause this video, and see if you can try that on your own. If you tried to do the previous exercise on your own, here are the solutions on the screen. With a 4-input OR gate, you need to have 4 columns in your truth table, 1 for each input, and then a 5th column for the output. And keep in mind the pattern that we discussed. Your very last input alternates between 0s and 1s, just 1, 0, 1, 1. The next column would be 2 0s, 2 1s, 2 0s, 2 1s, all the way down. The next column, 4 0s, 4 1s, 4 0s, 4 1s, and then the final column, 8 0s, 8 1s. And if you have a 4-input OR gate, that means the output is going to be high as long as any input is high, which happens virtually in every single row except the first one, when all 4 inputs are low. And then for the 4-input AND gate, the output is only going to be high when all 4 inputs are high, which only happens on the very last row. Truth table that represents a digital circuit with 2 inputs, A, B, and C. It's the out. If you.
All right. So regarding the inputs, guys, basically I already teach you on how to plot your inputs. It depends on the variables, right? If there are 2 input variable A and B, the combination would be 2 to the power n. So if n is 2, so 2 to the 2 is 4. So it means if there are only 2 variable, let's say we name it A and B, 2 input variables, so we have 4 input combination, right? So if 4 input combination, the first combination would be atong giingon sa video nga this one, no?
Expect to see at the output.
For a while, no? So 4 combination is 0 0 0 1 1 0 1 1. So it simply means there are 4. By the way, do you hear me? Do you hear me? Hello?
Yes, ma'am.
If there are 4 combination, so ang mahitabuan na isang first column nga least significant niya nga variable is the B1, no? Kaning B. So alternate iyang 0 1 0 1. So nga na ang pattern, no? Unya ikaduhang column tagduha ka 0 tagduha ka 1. So kung imo panitan-awon, this follows the mean terms or numerical number 0 1 2 3. Diba? Kay the equivalent binary number 0 having 2 input variable is kung 0 0 that's 0, 0 1 is 1, 1 0 is 2, 1 1 is 3. Nagets ra? So this is how we plot the input. So it doesn't matter unsay output dire, depende na unsay circuit na to. Mao ni nga question mark, mao ni combinational circuit, no? Combinational circuit, it's a circuit having no memory. It only depends, the input purely depends on the output. So mao na definition yun sa combinational circuit. So it could be unlimited number of input, nya question mark sa doon sa output depende sa input. Unya ang question mark ani is if unsay ibutang nato nga gate diha, let's say or gate ba na, ungate, not, or combination of all the gates, magdepende ang output niya. Pero ang input, kung pila ka input variable, dili gyud na ma-change ang pattern ana. Mao ra gyud ni atong plotting, no? So kung 3 input na sad, kung 3 input manibot pasabot sa video, kung magama mo og circuit example nya may siya 3 input, automatic,
So, if you only have two
automatic mo plot ka og variable, tulo 3 input variable, ma'am, if you represent your input variable as A, B, C, by the way, you could vary, pwede X, Y, Z, no? Any variable will do, but almost all of the books, ang gigamit nila is, for input, ang first letters, no? In the alphabet. For output, mo to yung mga last letters, like X, Y, Z, no? Or W, X, Y, Z, no? Mga ngana sa ng output. So anyway, it depends on your preference, but by usage, as always, kung input atong i-plot sa truth table, we're gonna be using the first letters in the alphabet and make it capital letters to represent variables. Ingani ang pag-plot of truth table. And then sa output, okay, you may have XYZ variable or sa mga last part. And then, magdepende sa dang output, as I said, it depends on the input. Kung unsay output, depende sa circuit nga ipagawas niya, no? So unsa man nga circuit kay nasa sud sa question mark. So ingani ra ang pattern magama ta og combinationan. So for 3 input guys, same pattern ang first list column, let's see the C column, iyang alternate is usa ka 0, usa ka 1, 0 1 0 1. Ang next nga column ana is tagduha ka 0, tagduha ka 1, and then and so on, di ba? Mura man ni 1 2 4 8, 16, no? Yan na siya, no? So, kani kay tulo man, taman 8. So, kung 1, so 0, 1, 0, 1 ang alternate niya. Kung 2, second column is to 0 to 1, to 0 to 1. Diri na po sa third is 4 zeros, 4 ones. Kaya kung 4 input, mahug nga, ang fourth column, tanawa na 8 ka 0 na 8 ka 1. Same pattern dire. 0, 1, 0, 1, usa-usa. Dire, tagduha ka 0, tagduha ka 1. Tag upat ka 0, upat ka 1, and so on, no? So kung 32 na 5 ka variable, so na po ni 16 ka 0 una, and then 16 ka 1. So ang output magdepende kung unsay ato ipagawas nga output. So that is why sa kani nga video na next nga
inputs to a circuit, C has output that will depend on the type of circuit that you have. In this case, ang ipakita sa video na atay 3 input nga OR gate. So kung 3 input nga OR gate, obviously kung 3 input, the way we plot our truth table is we're gonna be using the 3 input variable format, no? A, B, C. Kisa maning saba. Okay, and then sa ABC na atay ingani nga pattern sa column C is 0 1 0 1, then duha ka 0, duha ka 1 sa B, 4 zeros and 4 ones sa A. And then for the output, since it's an OR gate, no? So OR gate means you ORed all the variables. So kung mo ni mga input combination, magdepende ang output dire. So since OR gate man, kung naay high nga input, what does it mean by high input? If naay usa ka input nila 1, automatically the output is 1. That is why yung ani atong output. And the equation for our output is A plus B plus C, since it's an OR gate, no? So kung duha ra sad na, tama na sad ta diri sa 4. Kung sa may truth table niya 0 1 1 1, no? Nya kinapun-an man nato base sa input, kung naay mo high, bisag usa lang, 1 naman automatic sa OR gate. And then next nga example is kaning si 3 input, 3 input AND na pod, no? So si AND gate opposite ni OR gate. So kung naay usa ka input nga low sa within 3 input, so ano gani ang input combination? It's 3 input variable, so yung ani yung pattern na kanunay, the way we plot it, nasabtan lang pag-plot sa input, ani ta magsugod. Kaya ug dini masabtan, di gid mo kagama og combinational circuit. So nasabtan ra ang pag-plot sa truth table. Dali na lang ang diagram kay mag-base ka sa table. Ang unsay basihan nimo sa imong diagram, maunay table ni base sa table ang imong diagram, no? Ni logic diagram nimo. Kaning circuit dire, no? Logic circuit diagram. So
kung kanising ani ato ang sana input combination niya, AND gate siya. So si AND gate, if na usa ka input nga low, all the rest of the output will be low. So mo 1 na siya, mo high na siya if all the inputs are high. So mo na ngay ani iyahang table of inputs and outputs niya, mo ni iyahang circuit equation as well as logic diagram. And then gipangutana mo sa
That will
sunod,
depend on the type of and. Keep in mind the
natay
pattern of this
problem,
video
this one, you generate the truth table of a 4-input OR as well as 4-input AND. So sayon ra no, unsa na itong 4-input, upat na ka variable, so you plot all the inputs and then ang output you base it on what gate ang iyahang circuit. Kung OR gate, kung naay usa ka input nga high, all the rest of the output will be high. If AND gate, if naay usa ka input will be low, all the inputs will be low. Mo high ra to nga input if all the inputs are 1. Mo na si AND gate. Mo na nga iyahang truth table answer is kani. No? So, based on to nga exercise, mo ni iyahang output, no? So, naatay 4 input variable. So, 4 naman. So, A, B, C, D. First column would be alternates of 0, 1, 0, 1, 0, 1. Second column would be 2, 0, 2, 1, and so on. Third is 4, 0, 4, 1, 4, 0, 4, 1. And then the fourth column is 8 ka 0, 8 ka 1. Pareho ra sila og pattern kay 4 input maghihapon na ring AND gate, naglahi na lang sila sa output. So kung kung OR, if na usa ka input mo 1 aning upat ka input, ani niya, mo 1 ang output. Opposite si AND, kung na usa mo 0, na usa ka input mo 0, 0 ang output. Mo 1 ra ang AND kung 1 ang tanang input. So any question ani nga part? Nabay question? Before we'll proceed. Kay di ta kasabot ani, useless mo proceed ko. Kay mas ang discussion magkaanam og ka medyo complicated na, no? Question, please. Question sa pagplot og input unya pag-generate sa output based sa atong circuit nga himuon or i-represent sa diagram. Question? Please ask question. Malig-on nan, ma'am. Is it silence means understood? Is silence means understood ba? Basig na galibog? Sige, mopadayon ta sa video. Kay basig mas masabtan ang kalibog sa mopadayon ta, no? Okay. Thank you for the response.
Left. This is the truth table that represents a digital circuit with 2 inputs. And see if you can study behave with any. So now that we've gone over truth tables a little bit, now we can talk about combinational logic. With combinational logic, we can wire a group of and, or, and not gates together to accomplish a specific logic function. For example, first, we'll use a truth table to illustrate how any given circuit will behave with any input scenario. So when you have a combinational logic circuit, you're going to have a group of and, or, and not gates. And your truth table is going to describe how you expect that circuit to operate. So now we have an example. Example 1 shows a very, very simple combinational logic circuit. Notice that there are 3 inputs, input A, input B, and input C. Notice that inputs A and B go to an AND gate, and then the output of the AND gate is now an input to an OR gate with input C. And then you have the output. So the first thing we're going to do is generate a truth table for this circuit so that we know how the circuit is supposed to work. Your truth table will begin by having a column for A, B, and C. What we're also going to do is include one column for the output of each gate. So the output of this gate would be A and B, and we use multiplication to represent AND. So this column will represent what's coming out of the AND gate, which also acts as an input to the OR gate. Then our last column will represent what comes out of the OR gate. So since A and B as a group go into the OR gate, the output will be described as A and B with the multiplication sign for and then a plus sign for or, C. So once we have this truth table set up, we're going to fill in the inputs, starting with input C. Remember the pattern that we talked about before. 1, 0, 1, 1, all the way down. Then fill in input B. 2 zeros, 2 ones, 2 zeros, 2 ones, all the way down. Then fill in input A. 4 zeros, 4 ones. Now we're going to fill in this column right here, which is the output of the AND gate. So we're going to be taking column A, column B, and performing the AND operation. So we're going to do 0 and 0 and figure out what that is and write it in this box. 0 and 0, and that goes there. So that's what the next column is. So as you can see, 0 and 0 gives me a 0. 0 and 0 gives me a 0. 0 and 1 gives me a 0. 0 and 1 gives me 0. 1 and 0 gives me 0. 1 and 0 gives me 0. 1 and 1 gives me 1. 1 and 1 gives me 1. So we're just really using the truth table for an AND gate here to describe what's happening with the output right here. Now keep in mind this output is now an input to the OR gate. So for our last column, we're going to be taking input C and this column right here and performing the OR operation to find our output. So we have 0 or 0 is 0, 1 or 0 is 1, 0 or 0 is 0, 1 or 0 is 1, 0 or 0 is 0, 1 or 0 is 1, 0 or 1 is 1, and 1 or 1 is 1. Now that we have this truth table, we have a roadmap to understand how the circuit is supposed to work once we build it. We know that if we put inputs A, B, and C in each one of these combinations, this is what we expect to happen at the output. Remember from our last video using the breadboard, A, B, and C would be like the switches. So you would have these switches set high or low, depending on whether you wanted A, B, and C to be at 0 or 1. Remember that your output is an LED. So your light will only come on when you have these specific combinations of A, B, and C. So the ones in the truth table tell me when the light should come on based off of a specific combination of A, B, and C. Here's another example. Now we have it.
Okay, is the example 1 clear, guys? Is there any question for example 1? Question? Naaray question, anong ang output niya is ing animan? Okay? Yes, Rolien, wala ra ma'am. So, na substance. So, kung kani, actually, bisag unsay circuit ha, magdepende ang iyang output kung unsay circuit atong gibutang dire. Pero kung 3 input, maoro gyud ni ang input kung 3 input. Bisag unsa nga circuit ang output, ang input kung 3 input variable ang involved, ingani ang input combination. And then the way we plot our output depende na sa unsay circuit diagram na to. Okay ha? So kaniman yang circuit diagram na na trace ra nato, this agi kuha ang A and B input and then followed by the final output nga naa na si C, gi-org silang tanan, no? So na-gets, and then we have example 2 now.
1 or 0 is 1, 0 or if we put inputs A should come on based on another example of a combinational logic circuit. So let's make a truth table. For this table, we need our 3 inputs, input A, input B, and input C. Then I have a column for each gate. So I have a column to represent what comes out of the OR gate, a column to represent what comes out of the inverter, and a final column to represent the output. Remember that an inversion is represented with an over bar, and it goes over the entire group of what went in. A or B is what goes into the inverter, so we put a bar over the entire expression to represent what comes out. And then that entire thing goes into an AND gate with C, so we have a multiplication symbol to show the AND gate. And this output here is our expression. So now we're going to fill in the inputs of the truth table starting with input C. 1, 0, 1, 1 all the way down, then input B, 2 zeros, 2 ones all the way down, then input A, 4 zeros, 4 ones all the way down. Then I'm going to do this next column here, A or B. So I'm going to take column A, column B, and perform the OR function. And this is what I'll get. Remember, 0 or 0 would give me 0, 0 or 0 would give me 0, 0 or 1 gives me 1, 1 or 0 gives me 1, and then 1 or 1 gives me 1. Now, everything in this column is being fed into the inverter. So remember, the inverter is just going to give you the opposite of what went in. So the next column is going to represent what comes out of the inverter, which is just going to be the opposite of what went in. So the zeros become ones and the ones become zeros. Lastly, this column is going into the AND gate with input C. Now be careful here that you're looking at the correct columns. You're looking at input C as well as this column right here, and you're going to perform the AND function to get the output. And there's our output. We only have one time where this column and input C are both high, and it's right here. So this is the only time the light should come on when we build the circuit. The only time the LED will come on is when input A is 0, input B is 0, and input C is 1. Any other combination gives me a 0 at the output. Here's a third example for you to try.
Okay, how about example 2? Is the output clear? No question here. Question? Okay, masabtan ra ma'am. No question ma'am. Okay ha? Anyway, you can review this video and you may take note also. And you may fill in the blanks lang sa output niya. Kamoy magsuwat sa output in your seats kung gusto gyud mo nga makat-on, no? Nga di sa lang mumutan-aw sa output sa video. The moment the problem is given, ha? Ana ang pagtuon ani. Last thing is this one.
It's right here. So this is the only time. Any other combination gives me a 0 at the output. Here's a third example for you to try on your own.
Hey, you may try it on your seat. What would be the output based on that logic circuit? And it's a 3-input logic circuit. So, ay, na yung output. Yatag na. So, you may try it para makita ninyo kung i-check ninyo kung sakto ba ang output.
Any other combination. Here's a third example for you. The only time that A is 0. Here's a third example for you to try on your own. As well as this A is 0, and any other combination gives me an example for you to try on your own.
Okay, okay, is the output correct? Sige, pakita na ko ha. Natay tulo ka input combination, and then kwaon ninyo ang output sa first AND kaning BC, and then as well as the output of the second AND, unya i-OR ninyo to tanan, no? Output sa first, output sa second, and then the A input, no? So mo na ipang-OR ninyo tanan, no? So far, pag OR ninyo, unsay ni gawa, sakto ni nga truth table of inputs and outputs. Sakto ra? Okay, you may try it on your seat. I-trace ang input o output. Output sa first AND, which is the BC nga TL. Unya, ang input sa second AND gate is a B and A natiin. And then mo na output diha ang A ug B. And then ang OR gate, ang iyahang input is ang output sa duha ka gate kaning A ug B o B ug C as well as the A. So mo na OR niya, pinaka-OR output, no? So sakto ni mo ni pinaka-output ba? Wala na niya gipakita ang detailed sa duha ka gate gyud sa pagkuha. Output na diretso. Sakto ra? Yes, you trace kung sakto ba, no? So kung kaniuna, wala na niya gipakita ang output ni BC as well as output ni AB, no? Unya, ang kanina nga output yang gipakita kaning OR na output, no? So sige, please try to check in your seat. So, screenshot na ba? Just tell me in the GC, mga GCs ninyo or diri sa group sa atong chat box if the output, the overall output of the circuit is correct. Nasabtan? Okay, so can I proceed with my slides? We had already an intro discussion for combinational circuit. For the resources that I'll be giving you, the material that I'll be giving you are the different combinational circuits, no, commonly used, okay, in logic circuit. So I'll be giving you a PDF file discussion on the different so kani siya is kanang wala man siya standard kung unsa ni siya nga circuit. Ang ako i-present is tagaan ta mo combinational circuit nga naagid siya name, no, unsa siya nga circuit. Pero it's a combination of logic gates, no? That's why it's called combinational. So I may stop share this one to proceed with my discussion. Do you see my screen, guys?
Yes,
Yeah.
ma'am.
Okay. Okay, all right. So, do you hear me? Once again, do you hear me? Is my audio clear? Hello? Okay, sige. Yes, for this discussion, at the end of this, we will be introduced to the different combinational circuits, no? Demonstrate the operation of the mentioned circuit. Namely, we have the error detector circuit or parity generator circuit, the half and the full binary and BCD adder. And then we have, so actually we have to construct, no, those circuits and then verify those logic function of this combinational logic circuit. So topics to be involved are the following. So for this resource, you'll be introduced some sort of basics on parity generator circuit, the adder circuit, the half, the full, the binary, and BCD adder. And then the opposite of adder, which is the subtractor, encoder, decoder circuit, multiplexer, demultiplexer circuit, and the comparator. So, daghan siya. But then again, as I said, the very essence is you know how to create an inputs of those circuit as well as the output based on those behavior of those circuit being mentioned, no? So, akong role karon is i-mention ako unsa may how parity generator or error detector works so that you could determine its output with a given series of inputs and as well as an adder circuit and then a subtractor circuit and then as well as encoder, decoder circuit, opposite ng duha, multiplexer, demultiplexer, as well as comparator circuit. How it works, no? So well, so anyway, that's just medyo hanap-hanap atong figure. Anyway, you could see in the internet a clearer version or picture of this one. We will just be, ato lang ni siyang i-run through para ma-introduce lang, kung sa about ang kaning mga combination ng circuit. Well, for the error detector combination ng circuit, or nasa nga niya parity generator circuit, So it's a type of circuit wherein it could be an odd or even parity generation circuit. So when we say parity, guys, it would represent the number of zeros and ones, So when we say odd parity, the number of one is odd. When we say even parity, the number of parity is even, the number of one is even. So we have here which adds a single bit to the data to be transmitted. So that would be the definition of parity circuit, So for this, let's say for example, we have a transmission line here having two lines, the opposite lines, the out and the in, input lines, and then we have our parity gen in between our transmission line, and then these two parity generator in which we attach to each line would generate, it's either be an odd or even parity generator, So it says here that if there is an error, it should be our So kanisa to mention, the system is good only if an error occurs in a single transmission line. If there is an error on two transmission line, the error detector will see that everything is fine. So mo lang ni nakakuan ani nga circuit, So tungod kay dili niya ma-detect, kung duha na mo error, so that is why ang atong gigama is XOR, kay ma-1 man ang XOR kung ang silang duha ka input is dili pareho, di ba? Let's say 0, 1. So ito yung table ni XOR last time. If it has two different input, the output is 1. If pareho sila nga, o pareho ilang input, let's say both is 0, 0 and both is 1, 1, the output is 0. So kanina parity generator, if 0 ang output, it means no error daw. Unya, if 1 ang output, it means na ay error, So, mo na iyang boot pasabot, So, we have here na given 4-bit error detector circuit, the parity generator is incorporated both on the transmitting and receiving end. And if there is no error during transmission of data, let's say pag-transmit is 0, ang na-receive is 0, so it means ang pag-transmit is the input and then ang na-receive is 0, it means no error. Mo man ni XOR, And ma-determine lang muwa ng output if na error tungod kay dili sila magparehas, So gamit man ang circuit, yes, gamit kayo kanina combinational, Kay it would determine an error transmission, of a certain transmission line, So, if there is no error during the transmission of data, the parity bit at the receiver, the transmitting end will be equal, and the error indication output would be logic 0. However, if an error occurs during the transmission, the parity bit of the receiver will not be equal, to the parity of the transmitter. Therefore, the output indicator becomes 1. So, ani ang mga gamit sa logic circuit, guys, combinational, So, nahitabuan nagamit na to ang XOR circuit as well as gi-apply siya sa kaninga application, So ani nga side mo agi siya og kanang parity parity generator nga XOR ang iyahang paggawasan, to know, if there's an error or not. So mo gyud purpose ani nga circuit. So pwede ra sad ni ma-apply bisan dili lang sa transmission line if you want to know if there's an error or wala, no? So mo na siya agi-agi siya og unsa na parity generator so that maka-determine if there is an error or walay error. So mo ra joy role niya nga circuitry, no? So any question for this question? Yes. So to, nay question?
None so far man siguro, ma'am.
Sige, ma-proceed ta sa next na circuit, no? So anyway, you could post your question ha in your Google Classroom or nasad sa GC kung naalay kalibog. So well, for more other examples, you may watch, no, some YouTube tutorials on how parity generation is being done. Kanilang is gi-attach sa transmission line, no, mo yung application. So to determine error lang, again, no, if there is an error in transmission, the output is 1 for the circuit, and if no error, the output is 0. And then for the so well, di ara, no, di man gud ko kayo makadishanap-hanap dun siya, no. Even parity generator mo ni sud sa katong generator na to, no? Kung even tulo ka XOR ang involved, ang first two input usa ka XOR, ang second two input, last two input di ay usa ka XOR. So why lusot gyud, no? Kung nay error gyud ang data, gi-XOR pa gyud sa last. So mo na siya even parity. Nya diri gi-XNOR ang tumoy sa add parity. So ingani ang sud sa atong sana parity generator. Kung add parity generator, duha ka XOR gihapon ang first two input usa ka XOR, ang last two input another XOR, and then this one is XNOR ay bubble, no? So sige, no? Question for this, opposite ang add ug even, ha? Opposite sila, no? Opposite og output. Kay kari XOR ang tumoy is XNOR ang sa add. So far mo na isud sa parity generator na to dire. Mo na isud niya, no? Kung add or even siya, so naara nimo kung add imong gamiton or even, no? So ang pinaka-purpose lang is error detection sa signal nga misud, no, sa transmission line. And then another thing, application na kung mga gipakita, ha. So ang truth table ani pwede ka muna mo analyze sa truth table of inputs and outputs niya based sa unsa ang combinational circuit nga iyang agian, no. Kay sa mga previous na to nga video katong ganiha, gi-introduce naman how you plot truth table and how you could diagram it and how you could trace the output, no. So as well as kaninga combinational, kamo ni mag-create sa truth table of inputs and outputs, gihatag na ang diagram, no. Well, next, no, for other circuit, we have here for other circuit, kung other kay mura ra mo kag or circuit, no. So it's one of the most basic building blocks of calculator. So you know what? Inside your computer system is mga logic circuits ra gyud, no. And basic building blocks of calculator man. So actually, all tanang mga nahitabo inside sa computer system is mura siya calculator, no. Ang role ra ba jud sa calculator before is wala gyud subtraction, only addition. Because subtraction is still addition, but you are adding different signs, no. Kung may kang multiplication, it's an addition, but you are adding it multiple times. And then kung division, addition na daw gihapon, nara kay adding parts of a whole, mao man si division, no. So klaro, addition tanan, no. That's why other, especially half other, no, gitawag na siya og the basic building blocks of calculator and computer circuit. Why? It involves only two input variable combination, no. Its function is to add 2 bits in binary fashion. So let's say if two input variable, so So, natay duha ka input variable. We have A and B, and we have 4 input combination. So, if we added this input combination, let's say we added A and B, using this input combination, 0 plus 0, 0 plus 1, 1 plus 0, 1 plus 1, we could produce an output. We call it carry and, how do you read this? Carry and sum. No? So for 0 plus 0, we have 0 output, sum is 0, carry 0. And then for 0 and 1, nindot kay application, no? We added 0 plus 1, the output is 1, the sum is 1, carry 0. And if we added 1 plus 0, the output is 0, the output is 1 again, carry 0. And if we added 1 plus 1, the output is, the sum is 0, carry 1. So how we add our binary number, that's how our half adder functions, no? And if we draw its block diagram naman yung square, kani ang logic diagram, no? Equivalent circuit diagram niya. So, pag kani ko ng half adder, pwede ra og we put it in a box, series of inputs and outputs. Natay duha ka input AB, natay output carry and sum. So, if we draw using logical circuit, mahitabo ang duha ka output atong i-drawing, no? Kung atong tanaw ng inputs AB, ilang mga output, klaro na kayo. Si sum, kung imong tanawon si sum, na 1 siya diri, duha ka 1, kung ang duha ka input is lain-lain, meaning XOR na siya. Klaro ba? Basic, kinahanglan, tibanan ninyo itong truth table sa XOR, no? Importante kayo nga master ninyo para maka-represent, no? Maka-represent mo logic gate niya dito, no? And pwede sad nga si Ann, si Carrie, may imong tanawon with the input 0, A and B, ma-0 siya, ang iyang output ni Carrie kay 0 ug naay 0. Meaning, ungate siya. Ma-1 ra siya kung 1 tanang input. So, si Carrie, with inputs A here and B, so with inputs A man niya, kani siya is B, let's say for example, kana, no? Kung ang A of B is naay 0, it's either A of B 0, ma-1 na siya kung 1, ma-1 na siya kung 1 both. So, carry mo na iyahang logic gate. It represents an AND gate. Yeah, si sum, it represents an XOR tungod kay ma-1 siya kung 2 inputs are lain-lain, no? Bantay mo. So, mo na si sum. So, na-substance ang half adder circuit representing this truth table. Question na ni? Yeah, ma'am, what if pagamun ni ma'am o upat ka other circuit? Yes, nga itapo-tapo na to. So, una nang nanatay sana 4-bit other later, no? So, magka-complicate ang circuit, no? So, oy, nangano man 75 naman yung naminaw. Nagkalisod ang diskusyon, no? Kalibaw na siguro sila. So, question ani nga truth table before I proceed to full adder. Anong mao niyang circuit, mo niyang truth table, kani block diagram man ni usa. So, question sa other circuit. Half adder, sorry. Hoy, pangutana.
Wala man siguro, ma'am.
So, paano? Proceed ta sa lisod, no? So, lisod gamay. Okay, let's proceed to full other circuit, no? So, other circuit yapon pero full na, di ra half, no? Sa full other, its function is to perform addition of 3 bits na. So, tulo na i-add na to. Kung tulo, it involves 3 input variables, so it has 8 possible combination, no? So, for 2 to the power 3 man, so, natay ABC. Dili ni ma-change yung input, no? C column is 0, 1, 0, 1, 0, 1, and so on. Column B is 2, 0, 2, 1, and so on. Column A is 4, 0, 4, 1. Magdaog na sa carry o sum. So, as we notice here, it involves duha na ka half adder, no? So, una, iyang half adder si A, unya gidugangan ni C input. Another half adder. Ang outputs ni A ug B na carry ug sum, okay, mo na gisud, no? Gisud niya sa next nga half adder final, no? Sorry, ang sum unya ang first nga carry is niya sa mo ni pinaka full circuit niya kani block diagram ni nga circuit niya ang sud sa half adder gibungkag dire, no? First half adder is kana man, di ba? As we have previously ganiha, unya ang second half adder mao ni yung sud na. And then ang output sa last nga XOR mo ni sum, unya ang output sa last nga OR gate mo ni siya carry. So, kung ako tanaw, no? So, duha gyud po na ka half adder ang involved, iya rang gi-combine sa full adder, no? So, gingani para mas masabtan, duha ka half adder ang involved. No? Why? Tungod kay ang adder circuit, maura magyud ni ang basic niya nga circuit kaning half adder. Para mahimo siyang full, gidugangan siya another half adder. So, na full na, no? So, gisumpay mo ni iyang detailed diagram, logic diagram. Unya kani ang pinaka block simplified block diagram. Na input tulo ka input ABC. Unya full adder angan sa as kani nga block diagram, unya na siya carry in and then na siya sum. So, carry og sum ra mo output, unya tulo ka input. So, if there are 3 input, mo ni input combination, are you still with me? 74 na lang, no? And then, ang carry og sum mag-base sa atong input. Okay? So, for adding this one, tulo ka 0. So, let's check, no? For adding both 3, 0, we have an output sum is 0, carry is 0. And then 0, 0, 1. So, 0 plus 0 is 0. 0 plus 1, the sum is 1, carry 0, correct? 0, 1, 0. 0 plus 1 is 1. 1 plus 0 is 1, carry 0. So, for the first 3, wala pa carry. And then, ang carry na nasa last, kay duha naka 1 ang involved, no? 0 plus 1, 1. 1 plus 1 is 0, carry 1. And then, another 1. 1 plus 0 is 1. 1 plus 0 is 1, carry 0. And then, and so on. So, sakto na siya. You are going to plot, okay, all the carry and all the sum. So, saan pag-plot, no? So, kung imo nang tanahon, first half adder sa ta, no? So, ang first half adder na siya'y kani nga output carry, nga output sum. So, tama na ning first 4. Muna siya first adder, no? So, pag-plota na niya, si input A o B na siya output nga sum, si A ug B na siya output nga carry. So, asa man na pa dong? Si output sum, mo na pud na i-input niya sa next half adder together with C input. So, i-XOR na sila, mo na sum, and then, kaning duha ka, kaning output ni first sum, and si C, mo na sad na isud sa ikaduhang AND gate for the carry. And then, i-ording duha ka carry, so that makes it your only truth result sa truth table. So, once you check, dapat sakto na, no? Based sa kaning truth table, kung sa combination nga yung iso, dapat mo na yung mugawas diha. So far, mo na standard sa full adder circuit. So, question for this? Question? Na-question? Full adder. Okay, none so far. Thank you so much for the response. Clear lang, no? Sige. Let's proceed to binary, no? Binary adder, okay? Kasi tulo na ka full adder. Yeah, kani siya class mura ba og ang A nimo, let's say ang A upat ka input variable as well as si B upat ka input variable. So let's say si A kuno na siya input nga 1 0 0 1 og So, muna siya 1, ABC, kung mahog maninga. Gani siya A, so 1, 1, 0, 1. Yeah, si B, nasad siya inputs nga 1, 0, 1, 1, 0, 1, 1. So, ganyan na pag-add. So, mag-add tayo nga na lang, no? Diba? So, sa may output, ani kung mag-add tayo using atong addition of binary numbers. Ang output na kay 0, carry 1. 1 plus 1 is 0. Carry 1, 0. 0 ni. Carry 1. 1 plus 1 is 0. Carry 1. 0 plus 1, 0 plus 0 is 0. And then 1 plus 1 is 0 carry 1. 0 plus 1 is 1. 1. Sakto ba ni? 1, 1, 0, 0. Okay, sakto, no? Mo ni atong output 1, 1, 0, 0, 0. So kung ato ning subayon, upat kuno ka full adder circuit. Ganang upat man kay kung mag-add tag duha, okay? Usa na. Ganong naman tayo full adder man class. Tungod kay nanay carry nya sana natay input carry na, no? So mura magmahog nga first full adder nya ang carry 1 musud sa next full adder, ang carry 2 musud sa next full adder, ang carry 3 musud. So meaning tulo ka input. So meaning full adder atong gamiton sa first 3, and then there we have other pa lang kay duha pa may atong i-add, no? So ang least significant, so let's say 1 plus 1 duha pa man. So pwede ra have other ang implementation and in first least, no? And then na may mo involve nga carry, no? So na mo involve og wala, so mao gid ni ang circuitry ni binary adder, no? Binary usually it represents 4-bit binary number. So mo ni siya is function is to add two binary numbers, not just bits. So two binary number, unsa may number ang A, unsa may number represent ana 1101, unsa man na? That's 13, no? Si 1011 dots, unsa man nga number? 1011 that's 11. Sakto ba? Uy, sakto ba? Tingog ko no. So again, si binary adder it represents it adds two binary number, not just bits. Si half ug si full bits ra iyang ipang-add, no? Okay. So the substance si full sa to binary adder. Pinasabtan ra 13 plus 11 pila man na? Answer is 24. Sakto ba? 13 plus 11. 24. 1, 2, 4, 8, 16. So, 8 ug 16 yung may ni 1, meaning that's 24. So, kung ito na i-trace, so kamo na yung makahibaw. So, mao-day na, ma'am, nga. So, magka-complicate, no? Pwede po mumugama o binary adder nga kuan. Sana? Dili ra two binary numbers. Let's say, we create mo binary adder nga 3 binary numbers. Diba? No? Kaya ka? No? Kaya ra ba? So, kung 3, ano may circuit? So, that's the analysis, no? How about BCD adder? Ano yung basic sa BCD adder? Saan itong BCD adder? Binary coded adder. Decimal adder. So, saan yung binary coded? Ang numbers 0 and, for example, no? Kaning BCD kay ang number 0 to 9 represent siya 4-bit binary number, no? 0 is upat ka 0, 1 is 0001, and so on. Tama, 9. 9 is 1001, no? So, inigabot niyang 10, ang 1 i-represent sa 4-bit binary, ang 0 pod i-represent sa 4-bit. So, mo niyang buto sa bot. It is used in adding BCD number because a simple binary adder cannot perform this task, since the number in BCD code is only from 0 to 9. That is, ang number equivalent ana is, kada number nga decimal, representahan mo ni upat ka digit. 0 is 0000, ang 9 is 1001. Abot yung 10, ang 1, i-represent po ni mo upat ka digit, binary digit niya. Ang 0, i-represent sa ni mo upat ka digit. So, mo na yung buta sa bot niya. The number 10 here, ang binary number ni 10 kay 1010 man. While ang BCD niya, ang BCD ni 10 is in the form, ang 1, tagani mo BCD representation, ang 0, another BCD representation. Which is very, very different. Isla parehas ha. Ang 10 in binary is different from 10 in BCD. Nakuha? So, ma'am, saan mo nakapag-add, no? So, if we add BCD numbers in binary way, we add it in binary way. But, if a group produces a carry or its sum greater than 9, we have to add 6. Okay, so, sabtan, based sa example, no? Are you still with me, guys? Are you still with me? Other pa ta, ha? Hello? Ang hinay akong tingog. Kana, kusog? Hello? Hello, hello.
Hinay gapon, ma'am.
Inay gihapon? For a while, ha? Volume. Kana, guys. Kana. Okay na? Ano naman? Hello? How about this one? Ano guys? Usog na? Hello? Hello?
Kana, ma'am.
Kana, ma'am. Tugtog, ma'am.
Okay, siguro na, kuan lang na ho, no? Ang speaker. Sige, can I proceed? Naklaro ra tong ganina, ag BCD other class? Naklaro ra?
Wala kayo, ma'am.
Sos mo, para bagyo ilisod sabton, no? So, lisod. So, ako ang buto sa buto, BCD other ta, lahi siya sa binary other tungod kay ang numbers 0 to 9 ra iyang represent, no? Kanina dunggan, ha? Inikabot niya og 10, ang binary ni 10 kay 1010 man, unya, ang BCD ni 10 is dili 1010, which is 0001 kay ang 1 i-represent niya laing 4-bit binary niya si 0 pod. Mo na nga BCD og si binary nga 10, they are very different. So mo na ibot pa sa bot, no? So if we add BCD numbers, we use in binary way, pwede ra. But if a group produces a carry or its sum is greater than 9, we have to add 6 kuno. So, sa atong BCD other. So, tadaw na to ha. Let's say for example, mo ni iyang example, no? Kung mag-add ka og 57, decimal number niya siya, dili na siya 5710, plus 62 nga decimal number. So, kung mag-add ta ani, naagyo mo lapas og 9 ang carry, no? So, si binary, si decimal nga 57 og 62, we represent using BCD, unsa may BCD representation ni 5, 0101, 7, 0111. Nakuha? Unya, ang BCD representation ni 62, that's 57 base 10, ha? Dili na siya 5710. 62 base 10. Okay? 6 is 110. 0110, unya 2 nga BCD is 0010. Klaro ra? Hello?
Yes, ma'am.
Okay? And then, ang answer ani, kung mag-plus tag 57 plus 62, 199, base 10 ha? Base ni 10. 119 ba? 9 and then 11. Ano? 7 plus 2 is 9. And then, unsa na? Asakto ba niya ang sum? 57 plus 62 is 199. 9 and then 5 plus 5 plus 6 is 11. Okay. Tungod kay BCD addition, ang nahitabo atong i-add ang first digit sa 7 ug 2 which is 9, no? So this one not greater than 9. So i-bring down 9 na nato, no? Lahi ang iyang addition ha, dili siya normal addition. And then karing 5 ug 6 i-add na to, 11 ang answer. So meaning that's more than 9, greater than 9. So meaning greater than 9 man, we will add 6 kuno ana nga digit number, and answer will be carry na lang, no? So ang mahitabo, ay sorry guys, dili siya 199, it's 119, no? Sayop ang kaning answer, no? We have here 1 plus 0 is 1, and then 1 plus 1 is 0, carry 1, and then 1 plus 1 is 0, carry 1, 1 plus 1 is 0, carry 1. So moni itong answer 1 0 0 0 1 o 1 kana siya 119, no? So that's how we did BCD addition, no? Klaro ang so again, kung more than 9 ang carry, kung more than 9 ang answer na i-carry, meaning we added 6 to that answer, and then mo na itong unsa na BCD answer, no? So answer for this is 119. Dili siya 199, clerical error o niya. Base 10 na siya class ha. And then example B, the way we add BCD other using BCD other, mura ni medyo libog lang pero plus 6 lang kung more than 9, no? 38 decimal number base 10 plus 28 base 10 number. Ang answer daw niya is 66 in BCD addition. First is we added 8 and 8. Kung 8 and 8, natay, sana sabay answer na to ani. I-carry man na to ang answer. So meaning kani siya na may carry. So na plus than 9 daw. So we produce an n carry, meaning we added 6 to this answer of 40, kay ang last is give carry man na to dire. Plus 6, 6 ang answer, and then this one, take note na tay carry 1. Si 3 is 011, and then si 2 is 010. Then carry 1 man, so 0 na, carry 1. 1 plus 1 is 0, carry 1. 0 plus 1 is 1, bring down 1. So, mo na yung answer. So, not greater than 9 man ang 6. So, mo na yung answer niya, 66, ang binary addition answer. So, yan nilang timan ang BCD other. Kung mag-add kag BCD nga number, base 10 na siya nga number, let's say, niya, represent mo using BCD, each digit of the number, you represent 4-digit binary. O niya, ang pag-add nimo is mura kag nag-add og binary. Pero kung ang iyahang answer mula pas og 9, mo carry ka, meaning mo add kag 6 sa final answer. So, na-substance ang function ni BCD. Nihingay, sad, nihinay. Hello? Ano man eh? Hello? Hello, kana, maklaro? Ano man eh?
Yes, ma'am.
Mo lang tong timanan sa BCD other, guys. Kung mag-add ta o BCD other, using BCD other, decimal number na siya, unya imo i-represent using 4-bit binary number kada decimal digit. Unyang i-add nimo per digit, no? Mura ra kag-add og binary number. Pero ang iyahang answer kung mulapas og 9, mo carry man ka, so plus 6 ka, no? Plus 6 ka mo to yung final answer sa BCD. Klaro? Based sa example, no? Ora na yung difference niya, no? Mo plus 6 ra ka. Hello? Klaro pa ko?
Maklaro pa, ma'am.
Ang iyang circuit diagram is na siya'y usa ka half adder, tulo ka full adder. Unya, muagi siya og ang iyang carry gi-represent aning block diagram. It's a decoder circuit daw. A decoder will be itong i-detailed ang decoder later. So ang sud sa decoder naa siya'y AND gate, duha ka AND gate unya naa siya'y tulo ka input nga OR gate. Unya ang ilahang output ana gibutang pa gyud sa XOR together with two half adder nga gikan sa mga output sa duha ka full adder. Anyways, mas clearer ni siya the moment you receive also the PDF atong i-review mo ni iyahang pinaka circuit diagram. Well, mag-double check mo, let's see na amoy using this example kita hay na amoy inputs nya inyong ibutang dire, i-check ninyo kung unsay mogawas nga output. You be the one to produce the truth table here. Ang gihatag lang is block diagram as well as the circuit diagram, no? Kay bao na mo sa isud sa full adder, kay bao na sad mo sa isud sa half adder. That's the way we trace circuitry, no, using truth table. Truth table wala nagihatag kay nag-base tag example, no. Anyway, natay truth table sa half adder og full adder. Kani pwede ra man igdili ang truth table ani kay naa na may block diagram, na may logic diagram sa SOD, no. SOD sa atong decoder, no. So far introduce ra mo unsay mga combinational circuit. So far mo to siya adder, no. And si subtractor, taas yun nga discussion, no? As I mentioned last time, we will be using complement, no? Kung mag-subtract ta, wala mang goy negative number, so we could represent negative number using complementation. So si subtractor, mura ra gyapon ig adder. Ang difference lang niya is, let's see kani atong circuit, gi-invert na to ang iyahang subtrahend. Anya, na ay inverter sa subtrahend. Let's say sa B, mo man ay subtrahend natay minuin ang A. Gi-invert ang B, unya kung atong tan-awon, maura siya circuitry, nalak siya XOR diri sa atong mga sum, no? Unya another pag yun hot o nga other, which is a half other, no, sa ubos. So mura siya full other. Ang difference lang is naa siya'y inverter sa atong subtrahend, no? So sige, example, the way we subtract binary number is we use complementation, no? So ang complements sa mga exam na ko class nalang kay computation gamay, let's say sa BCD adder, sa full adder, no? Or natay gamay nga drawing of diagrams. Pero anyways, kasabot lang mo sa table of inputs and outputs and every operation of which dali ra siya, no? So for using complementation, natay duha ka klase nga complement, using ones complement o twos complement, no? So mo ni sa subtractor nga principle, no? So let's say unsa may example og gamit tag complement. Kung moingon kag ones complement, let's say natay decimal number nga 25, 40 o 10. Do you hear me? Do you still hear me?
Yes, ma'am.
Yes, ma'am.
So kung naatay numbers 25, 40 ug 10, kuha na to ang binary ana unya. After that, ang ones complement ani niya nga mga number, let's say mo ni number 25, mo ni binary niya 11001, 101000, mo na si 40. Ang 10 is 1010. Ang iyang complement is we invert all the zeros into ones. So, let's say for example, si 11001, ang ones complement ana niya is gibali na to tanang 1 into 0 o tanang 0 into 1. Nagets? So, 11001 is 00110. And then 40, 1010000, tanang 1 gihimong 0, tanang 0 gihimong 1. As well as ang 10, 10100101. Clear? That's how simple is one's complement. Okay? Unya, si two's complement, the way we implement two's complement is one's complement plus 1. Sa to? Two's complement man, one's complement plus 1. So may bot pa sa bot? Kung 25 ang numero, at gikuha ang binary niya, gikuha na itong one's complement, ang tanang 1 gihimong 0, and tanang 0 gihimong 1, o ni one's complement, plus 1, giplasa na to ang 1, ang one's complement niya, mo na ni two's complement, kining nasa boss. Two's complement ni 25, ug two's complement ni 40. So sayon na, one's complement ug two's complement. Ma'am, para asa man na, anong kwaon man na nato, no? Kay, in subtracting two numbers, let's say 26 minus 12, may problema ni kay ang answer kay di man negative, no? Dali ra, no? Normally, we get the binary of 26, we get the binary of 12. Okay? Pero di ta mo subtract dito. So, unsay buhaton? I-change pa nimo una ang kaning subtrahe nimo, i-change niyo into one's complement. Kay one's complement pa man ta. Unsa gani one's complement? The inversion of the binary equivalent of your subtrahend. Ang reverse ni 12 is kani 1, no? Mo ni reverse, no? So, ang reverse niya, mo na ni imong add. Take note ha, di ka mag-subtract. You add the one's complement of your subtrahend. So, you reverse, mura bitaw nag-invert the sign and proceed to addition. Di ba yung ana man ng algebra, no? Hello. Invert the sign, invert the subtrahend and proceed to addition. So kung mag-add ka niya, that's the invert, natay makuhang answer, no? So, ang end carry niya, unsay answer ni class? 26 plus the one's complement of 12. Okay? So, unsa may one's complement ni 12? This one, 10011. Okay, so you add it, 1, 0, carry 1, 1, bring down 1, and then 0, carry 1. So, natay end carry nga 1. So, kung using one's complement, ang end carry nga 1 is we add it to the final answer. So, mo na nga makakuha tag answer nga 14, no? So, it's positive 14. Kay kung imong tan-awon man god og mag-add ka og one's complement ni 12, di magyud mao ng answer. Pero ang take note nga natay carry man, so gi-add ang 1 carry, gi-add na to ang carry sa final answer ni one's complement ni 12 o 26, we get 14. So 14 masad ang answer diri. So tiwan ni ha, kana siya guys kung positive ang answer. How about kung negative ang answer gibali? Mas dako ang kari nga part, no? Mas dako si subtrahend kaysa minuhin. So, saon man na. Negative ang answer. Negative 14. So, unsay buhaton class kung negative 14 ang answer, no? Hinay na sa dakong tingog. Minaw ha?
Okay ra, ma'am.
Okay, kung negative 14, take note, gikuha po na to ang nanatani kani. 12 minus 26, so meaning negative ang atong answer. So we change the subtrahend, we make it ones complement, and then proceed to addition. Onya, so si addition, pareho rin pag nakuha na tong answer diri, di ba? Maura ba? Ay bali di ay. Ang ato din gihimong kuan minuin is ang katong 26 na. So 12 minus 26, 26 gikuha na to ones complement. So mao na ni ihang ones complement karon. Sige, gi-add na to, lahi di ato nakuhang answer, dili pareho diri, no? So ang kani daw nga 1 nga end carry, na ba end carry sad? K1, we add 0, 0 carry 1. 0 carry 1. So mahimo daw ni siyang negative sign. It signifies negative sign. So mura ra tag magsuwat og ingani, no? Ang answer na gud nato ani is kaning 0001. Kanira niya. Balihon na siya. Kuha na to ang ones complement niya, negative 110, negative 14 man ang answer. So kanik daw 1 indicates negative sign unya. Kung ato ng another kaduha ka mag ones complement. Ones complement sa subtrahend ug ones complement sa final answer. So mo na maka-indicate og negative answer. So medyo daghang timan-an. Pag abot ni binary, subtractor, no? Kadto tanan nga concept, i-implement to siya using logic circuit. Sayon ra no. So kana siya tanan, no? So anyway, other circuit ra na, no? Other ra na, either full or binary adder, no? Full adder or binary adder. So murag mo nga binary adder na kay duha ka duha ka 2-digit number, no? Girepresentahan na to binary equivalent. So again, kung negative number, kaduha ka mag ones complement. Ang subtrahend ug ang final answer. Unya katong end carry nga 1, that indicates a negative sign daw, no? So ang example to ana is ipakita ra niya kung gamay ang minuin ug subtrahend, mao ra gihapon ang process. So you may review kung sakto ba ning 32 minus 25 unya, or the opposite, 25 minus 32. Same process with first example. Pero take note, kung positive ang answer, kung positive, ang end carry plus 1 sa final answer. Kung negative ang answer, ang end carry, himong negative sign niya, i-ones complement pag yun ang final answer. So, maranay timanan. So far mo na si ones complement. So, how about two's complement? So, maura gyapon ni ones complement, naratay plus 1. Maura ang implementation yun, no? Nara kay plus 1, no? So, ni two's complement. So, anyways, gipakita ra na to sa example. Ang two's complement is one's complement plus 1. So, kung giunsa ni siya paggamit, makapareho ra sa one's complement. Pero lahi ang iyahang implementation sa complementation na ay plus 1, no? So, nagets, mao ni iyahang circuit. Gi-complement ang unsa na ang iyang subtrahend nya naatay XOR dire, no? XOR ning atong and carry, no? Unya mo na po gisud sa half other circuit, no? Final circuit na ni siya, no? So far mo ni si full subtractor. Mulayo na pud akong kuan, mahinay, no? How about encoder combinational circuit, no? Kaya pa class? Other subtractor, maura gyapon ng other, nalang kay i-complement, nalang kay reverse, no? Si encoder combinational, it's a circuit that produces reverse output to that of the decoder. So, sa maning si decoder, sige, opposite siya ni, encoder opposite ni decoder. So, sangan nga encode, no? Encoding signals, decode is opposite, no? Ang opposite nila ni is kung unsay input ni decode, mahimo ng output ni encode, no? Bali, no? Or vice versa. So, ang iyaha ang input is 2 to the power n input lines and n output lines. So, what does it mean? Kung na ako'y 2 to the 4 encoder input, so ang iyang output would be 2 output lang, no? 2 to the 2 1, no? So, 2 to the n input lines and n output lines. Opposite si encoder, no? It's categorized as lines of bits or bits code converter. And these circuits are responsible for digital code conversion. Magamit ni siya sa atong digicom, si encoder-decoder, no? They require, we have here digital and computer system because they're required because there is necessity in converting a human code form into binary code from or one binary code into another. So, gamit ni siya kung mag-convert kag binary to decimal, hex to decimal, binary, no? And so on. So, for example, na ako'y input nga 0 to 9, no? So, ang iyang buhaton is gama kag truth table ani naa siya'y kintahay 9 inputs lang iyang gibutang, so mahitabo nga kung 9 mo involve man nag 4 digit variable, no? So 0 to 9 na 4 digit na, no? Tungod kay maka-represent kasi imong truth table ana 0 to 9 upat naman ka digit ang ma-involve. So meaning don't care na ang 10 to 15. So magama kag truth table ana combination 0 to appeal si 0 kay 1 to 9 naman ang iyang tagaag output ani, no? So meaning magama ko diri og sana si encoder, magama kog truth table ni encoder of inputs niya. Ang outputs niya is kuan daw A, B, C, D. D is the least significant bit on niya si A most significant bit si D bali di ay least significant si A, no? So ang nahitabo ni encoder kanang it encodes, okay? Let's say na atay unsa na hex numbers, no? Or decimal numbers to be represented by a hex, no? Number. So mo ni role ni encoder, no? So mahitabo kung mag-truth table ka ni pila ka combination kung 4 variable output 16 combination, no? So numbers 0 to 16. Okay? So ang output niya, so tanawa iyang output ang E is so kung magama kag truth table ani again, gama kag truth table of inputs and outputs, encoder. So, atong drawing mo na da ng output sa to. Bali, no? D, bali man siya. Ang most significant is D. Least significant si A. So, meaning A ang tumoy. A, B, C, D, no? And then, ang iyahang input combination is kung 0 to 9, don't care na ang 10 to 16. 15, I mean, no? Unya, tanang, so mo ni iyahang output, no? So, katutan ng, hindi ko kapakita o, for a while, ha? Please, ko. So, meaning, kay 2 to the power n man ang input lines niya, so 2 to the power 4 ni, input, unya, n output. So, ang output is upat lang ka, variable. Unya, bali ni siya ni decoder, no? So, kung natin nga ni nga encoder, kung ato ni i-decode, mahug nga kaning output mao na ni input niya, ang output is carrying input diri. So si decoder na example, sorry, hinay na sad to. It's a combinational circuit that converts a binary bit of n input lines to a maximum of 2 to the power n output lines. So balisad. So kani siya na siya 3 input binary na siya 8 ka output binary, no? So gingani pag-represent, no? Let's say 0 0 0, so mo ni output 0. So naa sa 0 tanan, no? Inverter, after inverter ang first input niya 0 0 1 and so on, yung mga input combination. So mo na iyang output tagsa-tagsa, mo na si decode. Opposite ni encoder, no? So again, ang timanan lang, no? Kung encoder to do the n input lines, si decoder n input lines. So ang input ni encoder mo ni output ni decoder. Vice versa, no? And then medyo sayo na ning si multiplexer. I'll be giving video also for multiplexer as well as kaning mga combinational circuit. I try my best, no? I-upload na ko tanang materials, no? Naana ko yung first two for more substance na to, no? So ako lang tiwason, multiplexer na ko yung video ani later. And then si sana comparator circuit, no? Multiplexer, it's a data selector circuit that selects one from many input lines through data select control bit. So the data select DS chooses it's either A or B, will transfer its data to the output. And when DS is 1 and the AND gate where input B is connected automatically produces a 0 output. And whatever data we introduce at input A becomes the output of the data. So that switch analogy shows clearly how our data select controls our multiplexer, no? The transfer of output. So, kung na daw tay XY input, our output is A, B, C, D, no? So, let's say for example, X, Y, so natay combination of 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. So, nag-base ani. Mo ni muso dire unya natay data select, no? So our output will be based on kay or man dire. So kung unsay mo enable, kung A ba, kung B, kung C or D, no? So naatay enabled circuit, no? So mo na iyang logic diagram, and then for this kani siya 2 input, kani siya 3 input, no? And then the opposite of that is a data distributor or the demux, no? Ang iyahang imbis nga ang iyang selector is kadto na pong sana ang iyahang input sa imuhang multiplexer mo na say output diri. Okay? So nabali na, no? So opposite sa di silang duha, no? So ang iyang purpose is it has only one single input line, so bali, but many output. Onya, sige, I'll be showing you the video for multiplexer for more understanding, and then I'll finish comparator. Comparator circuit, it only checks and compare two bits or sometimes two binary word, no? So they use in terms of equal, not equal, greater than, or less equal. Let's say na ako'y binary, na ako'y representation nga A less than B, I could use this truth table. Muwan lang siya if A is greater than B or A is less than B. So kung A less than B, A greater than B, ni 1 siya diri. Kay ang A 1, B is 0. Unya if A less than B, bali. A is 0, B is 1. Mo ni yung truth table. ungate man, yung gigamit. So, kung ungate, so mo yung output nimo, mo may output, no? Muwan lang. Sorry, yung gibali ang butangan yung inverter ang B, so ma-1-1 na. So, output is 1. Ang iyang gibutangan pag inverter is 0, meaning ang input ani 1-0. So, mo nang mo-1. Diri sad, ang output diri is 0-1. So, mo-1 siya. So, kung comparator circuit, what if ang imong pagaman og table is A is equal B? Unsa man itong ato ang logic circuit ani? Kung A less than B, kani iyang logic circuit. Kung no, greater than B. Kung A less than B, kani iyang logic circuit. How about A equal to B? Unsa imong logic circuit? A ug B nga nay inverter. Unya, duha ka buok. Napot sa ubos, A ug B nga walay inverter. Okay? Unya, nay inverter sa output kay 0 man. No? Nay inverter sa tumoy. Nakuha? No? So, kung A is equal to B, unsa may itong diagram? So, muna siya comparator. So, what if i-appeal tong duha? So, taas-taas inyuhang logic circuit, no? Dili ra kaning duha na pay A equal to B, no? So far, I know nga di mag-graphs diretso. For further, kuan lang, na ko'y gamayng minutes remaining, I need to show the video on multiplexer for better understanding on combinational circuit. Okay, let me share screen for a while.
We have already completed our combinational circuits. Now I will upload series of presentations involving different problems in combinational circuits. I will do
By the way, is the video clear ang audio? Clear lang?
Yes, ma'am. Clear audio.
Ma'am. We have already completed our combinational circuits. Now I will upload series of presentations involving different problems in combinational circuits. I will do the same for our sequential circuits also when we are done with it, and this is very helpful for you to understand the course and also revise the different topics that you have studied. I will take different examples from the competitive exams, and all the examples are very good. It will cover a very vast topics and it will help you to understand key concepts and also the implementation of the theory that you have already learned. Now, before actually going to the question number 1, I will explain you few things about this series of presentations. Every part like this one, this is the part 1 for the practice problems on combinational circuits, will have 2 problems. Okay, and each problem is selected very carefully so that you are having a greater understanding of different topics. So let's move to our question number 1. In this you can see a circuit on the right hand side of your screen, and we have to find out what is the value of S, the Boolean expression for S, and then we have to check from our options that which one is not S. So what will be our steps to solve this problem? You can see there is a 4:1 marks. So the first thing that we have to do is to do the analysis of this multiplexer, and I will say this is the output of my multiplexer and its name is Y. So our first step is to find out the value of Y, then we can simply find out the value for your S. So let's do it. You can see that the selector variables are AB, if this is S0, S1, and the selector variable plays a very important role in the determination of the output. So we will make the truth table. S1, S0 are the two selector variables for 4 cross 1 marks, and S1 in this case is A and S0 is in this case is B. The output is Y. Now for combinations, let me write it down quickly. Now your Y is simply I0, I1, I2, I3. You know how the multiplexer works. When it is 0 0, the I0 will be linked to your output. 0 1, I1 is linked. 1 0, I2 is linked, and 1 1, I3 is linked. Now we have to find out the Boolean expression for Y. So Y is equal to A complement B complement I0 from the first combination, or A complement B I1 from the second combination, or A B complement I2 A B I3. Now you can see from the problem that the values of I0, I1, I2 and I3 is already been mentioned. I0 and I3 are 0, and I1 and I2 are having the value equal to 1. So I will replace them. I0 is now 0, I1 is 1, I2 is also 1, and I3 is 0. So Y is equal to A complement B or AB complement. As it is 0 and the AND operation with 0 gives us 0, that's why I have neglected the first and the last minterm. Similarly, the AND operation with 1 gives us the same entity, therefore I am having A complement B or AB complement. Now if you remember from the logic gates, the A complement B or AB complement is equal to A XOR B simply. So this is the value of Y, and now we can find out the value of S. So S is Y XOR 1, and I can open it like Y complement 1 complement or Y and 1. Now you can see that 1 complement gives us 0 and the AND operation with 0 is 0. So 0 or Y, and it is equal to Y. So this S is
Okay, nasabtan ra ang video. S is the XNOR of X is XNOR of XNOR tungod sa bubble, no? Y and 1. Sakto ba? So, kani nga output iyang gibungkag, no? Iyang gibungkag ang kaning XNOR. So, unsa may iyahang bungkagon ani kaning Y sana gi-bar niya and then plus kani mo man ni XNOR, no? Ang negative sa duha or with positive sa duha, no? So okay, that makes it kung ang 1 complement, so may 1 complement 0 man, so 0 times na what also na bar also na not Y is 0 plus Y times 1 is Y. So that is why S is now equal to Y. Unya, diri sa new side, so this is how you expand the equation of your multiplexer, no? So all the mean terms. So let's continue the video. Sorry.
is equal to Y, and Y is A XOR B. So S is simply A XOR B, or I can write it as A complement B or B complement A. So this is what we have to find out in this problem. Now the important thing comes in which we have to check for our answer from these different options. Now if I talk about the XOR combination, then it is odd ones detector. So if I say this is my minterm M0, M1, M2, M3, and Y is equal to S, that's why 0 1 1 0 is the value for our S. And if I write S in terms of minterm, then it comes as summation M. This is M1 M2, so 1 2, and if I write it in terms of max term, then pi 0 3. I will write min terms for which s is 0. That's why m0, m3 is here. So this is what we have in terms of min terms and max term. So the option A is definitely representing our s. Option B is also representing our S, XOR gate with AB as input, and option C is also representing our S. That's why A, B, C are correct, then definitely D is wrong. And also you can see that A complement B complement or AB is equal to A XOR B, which is definitely not equal to our S. So D is the answer of this question, and it is all you have to do in this problem. Now let's move to our example number 2.
By the way, you may take screenshot on the solution so that you can review how it is done. Anyway, you could review the video also. And let's proceed to problem 2.
And in this also there is a mux involved, and this time it is 8 is to 1 mux, and you have to find out the function x. Here this is x, and definitely function x is having the variables a, b, c, d, the 3 selector variables, and d as the input. Now you have to find out the value of x. That you can do very easily. When there are 3 selector variables, we are having 8 possible combinations. So let's make them quickly. Zero one zero one zero one zero one. Okay, and the output is x. So the input is simply I0, I1, I2, I3, I4, I5, I6, and I7. Now we have to find out the Boolean expression for x. So x is equal to A complement B complement C complement I0. I will write it down very quickly. You can also do it by yourself. A complement B C complement I2, A complement B C I3, A B complement C complement I4, A B complement C I5, A B C complement I6, A B C I7. Now the only thing that we need to do is to put the values of I0, I1, I2, I3, I4, I5, I6 and I7 from the question like we did in the last problem. So I0 is 0. You can see from here, you can see it is 0. So this will be 0. I1 you can see is equal to D. So I'm having A complement B complement C D, and I2 is also equal to 0, so this will be 0. I3 is 0. I4 is 1. You can see I4 is 1. So I will write it A, sorry, this is A B complement C complement, or I5 is D complement, so A B complement C D complement, or I6 is 0 and I7 is 0, so the last two min terms are also 0. Now let's see what we got. We got A complement B complement C D, A B complement C complement, A B complement C D complement. So if I am having 4 variables, then there are 16 possibilities, and we have to write down the min terms and max terms depending upon that 4 variables. So let's try to find it out without writing the truth table. Let's see how to do it. A complement means 0, B complement means 0, C is 1, D is 1. And what number is this? 0, 0, 1, 1. It is 3, of course. So if I write in terms of min terms, I'm having 3. A B complement C complement, this is minimal form of the min term, so we have to make it canonical. D is not present, so definitely it was like A B complement C complement and D or D complement. That's why D became 1. So I can open it and I'm having A B complement C complement D, or A B complement C complement D complement. We expanded it and make it canonical, writing it in the form that we got from the truth table. So I'm having A B complement C complement D. It means 1 0 0 1, and this is what? 8 plus 1 is 9. So 9 is also my minterm. And A B complement C complement D, it means 1 0 0 0. It means 8. And A B complement C D complement, it means 1 0 1 0. This is definitely 8 plus 2, my 10. So in terms of main terms, I'm having 3 9 8 10. So definitely option A is correct, 3 9 8 10. And when there is 3 9 8 10, the remaining thing, it means 0 1 2 4 5 6 7 11 12 13 15 is my max term. So option C is correct, because you can see in this 10 is involved and 10 is my min term, so it can't be my max term. So option A and C is the correct answer for this problem. I hope you got it. So please feel free to comment your views about this initiative that I have taken to let you practice the different problems involved in the topic, so that you are having a better grip on this subject. After all, I want you to score maximum in the digital electronics. So please feel free to post the feedback. This is all for this presentation.
Okay, all right. So for the, at least for the multiplexer, you know already how you're gonna represent, how you're gonna interpret, what do you call this, inputs and the output, no? And how you gonna write, you represent using min terms and max terms also. Is the video supplemental for your knowledge, guys? Any feedback for the video being shown? Naglibog. Daghan na kayo. So, anyways, guys, I'll be giving some more videos na now nako unsay akong ma-send pa, no? For those two videos, very helpful na to siya, no? Of course, for the combinational circuit being introduced, any circuit, as long as aware mo unsa ang paggama og truth table, its combination of inputs and outputs, and how it works, the circuit, how it works, sayon ra ang combinational circuits. And familiarity of combinational circuit will lead you to a skill that you could create a project out of nowhere, no? Pwede to i-combine sila tanan, no? So again, remember, kung combinational circuit, the output depend merely on your input based on how the logic circuit works also. Ato nga output. And wala siya memory. So later, we'll be discussing sequential after combinational. Na siya memory through flip-flops. So far, that's all for this afternoon. I guess I'm on time, no? Question, guys? I'll be sending the two videos. Anyway, one video is now on your Google Classroom as well as this material. For the activity, katong word problem ngayong gihimo, tidbits lang sa combinational, no? Later, I'll be sending you activities, more of it, for combinational, and let's try to answer. No? I-answer to ninyo, no? And then, for the midterm exam, so I guess until, so I'll just be telling you the coverage for that. Anyway, for next week, you'll be finishing until next week your Lab 5. Sa gani ang Lab 5 na to? Katong Laboratory 5, it's all about XOR, after universal. And then, ang Lab 6, it's all about Boolean algebra theory. No? Lab 7, manatong natay encoder, natay combinational up to Lab 10. So, for next week, until next week, you will be finishing Lab 5. And then, another week would be Lab 6. And then, maybe I could give you quiz 2. And then, midterm exam on the following week. So, question? Midterm, I guess it's around, kato akong ipakita ang calendar after kalagkalang ang midterm, no? Coverage is, hopefully, bisang makover na to ang whole logic circuits, no? Taman, K-map, word problem. Mo na yung pinaka-minimum coverage. So, question? Okay, so it's already 4:30. If no further question, please send me the attendance right after per section. I'll be sending you the materials in your Google Classroom. Okay, any concern, guys? If no more concern, that's all for this meeting. Thank you for this meeting, guys, for responding. I'll be stop sharing the screen now.
Thank you, ma'am.
Thank you, ma'am.
Okay, let's end the recording now. Thank you, guys. You may leave now. That's all for today.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.